Hey guys, what's up? Welcome back to episode 2 of Quadratics. In the previous episode, episode 1, if you have not seen it yet, please check the link in the description below. And in episode 1, we discussed and discovered certain forms of writing a quadratic equation: the standard form, the factored form, and the vertex form. And in order to learn how to maneuver between them, we first need to learn how to factor and the special rules of factoring. So the next couple of videos are going to be focused on factoring and their special rules. So let's go ahead and start out with a simple equation or a simple expression, and then we will evaluate it. Let's do this. We know what x times x is, right? That's going to be x squared. Okay. So then, if we have x times x is x squared, then what is x plus 7 times x? That would be x times x and then x times 7. And so we have x squared plus 7x. Now, if we have something like this, but this one is also plus 7. So if we have x plus 7 times x plus 7, what do we get in this case? Well, then what we need to do is what a technique called foiling, where you multiply the first one with the first one, then you multiply the first term of the first multiplier with the second term of the second multiplier, and then you move on to this one. So we'd have 7 times x and then 7 times 7. So if I add that up all together, I have x squared plus x times 7 is 7x, and then again 7 times x is 7x, and then 7 times 7 is 49. So then if I go ahead and combine like terms, which is these two right here, I'm going to go ahead and get x squared plus 14x plus 49. Do you guys see a pattern? Actually, here, let me show you guys another one first. So, remember how... Okay, here, let me erase all this really quickly. Okay, so we found that x plus 7 whole squared, because we're multiplying x plus 7 times itself, so x plus 7 whole squared equals x squared plus 14x plus 49. Okay, so then what if we do x plus 3? Let's think about that. If we have x plus 3 times x plus 3, then we will have x times x is x squared. Then we will have 3x, so add a 3x, and then we're going to have 3x again. And then we're going to have 3 times 3 is 9, plus 9. So that's going to equal out to x squared plus 6x plus 9. So let me go ahead and shorten this up and then write it more concise. Okay, so now we've also found out that x plus 3 whole square equals x squared plus 6x plus 9. Okay, now let's try another one. Let's do x times 11. X plus 11 whole square. So if we do x plus 11 times x plus 11, we're going to get, again, our first term is going to be x squared. Then we're going to have 11x. We're going to have another 11x. Then we're going to have 11 times 11, which is 121. And then if we simplify that, we have x squared plus 22x plus 121, if I'm correct. So then let's go ahead and write that in as well. Do you guys see a pattern yet? I know I see one. And the pattern is this. When we have a number whole squared, like it's x plus 7, x plus 3, x plus 11, it always seems to be that the first term is x squared, right? And this first term here is x. So I'm guessing that this right here is going to be this squared. So that means that it's always the first term squared plus, and then this is 14x, and this is 7. Yet this is 6x, and this is 3. And then here, this is 22x, and that's 11. I see that if you divide 14x over 7, you're going to get 2x. If you divide 3x divided by 3, then you're going to get 2x again. If you do 22x over 11, you're also going to get 2x. So the pattern there is we're going to be multiplying by a 2 and an x. So, and the reason we multiply by an x is because our first term is an x, right here. And then our last term seems to be 49 for this one. 7 times 7 is 49. 3 times 3 is 9. 11 times 11 is 121. So you guys see the pattern yet? So the pattern is what we call a perfect square trinomial, which is a plus b whole square equals a squared, just like this is x squared here. This one's going to be a squared. And then we have, this is 14, and that's 7, so it's going to be 2 times 14. And then there's an x there, so I'm guessing that it's going to be 2 times x. So our x in this case here is a, and we're multiplying this times 2. So we're going to have plus 2 times a times b. And then our last term always seems to be the last term squared. So 7 times 7 is 49, 3 times 3 is 9, 11 times 11 is 121. So that means it's going to be plus b squared. And so this right here is our perfect square trinomial. This is something that you will probably need for the rest of your life, if you don't already use it. And that is one thing to pay attention for as we look at our next pattern. So we've already discovered that a plus b whole square equals a squared plus 2ab plus b squared, right? So then what happens if we have a minus b whole square? Will it be the same, or will both of them be negative? Let's find out by using some real numbers first. So if we have x minus 7 whole squared, let's go ahead and try that out. We're going to have what? We're going to have, again, x squared. So I'm guessing the a squared rule stays the same. And now we're going to have, x times x squared. Then we're going to have negative 7 times x, which is minus 7x. And then we're going to have, again, minus 7x. And then we're going to have negative 7 times negative 7, which is still 49. So let's try that again with one more before we start looking for patterns. X minus 3 squared equals x squared minus 3x, because we multiply that by that right there. And then we need to do that one more time. So it's going to be minus 3x. And then we're going to have to do plus 9, because then we have to do 3 times 3. So, or negative 3 times negative 3, sorry. So now we have x squared minus 14x plus 49. But wait a minute, right here it was plus 14x. And then right here we have x squared minus 6x, if we combine like terms, plus 9. But then right here we had a plus 6x. And then right here we had a plus, didn't we? We had an a plus b squared right here. Well, that's our second pattern right there. It's going to be, it's also called a perfect square trinomial. And this one is the exact same thing except for a minus b whole square. A minus b whole square. And that equals a times a is a squared, right? We already accomplished that and discovered that. Then instead of having a plus here, because this sign is plus, this sign I'm guessing is also plus, since this sign right here is minus, we know that this sign right here has to be minus as well, because that's part of our pattern. So now we're going to have a squared minus the same value of 2ab, and then plus b squared. So these are the two perfect square trinomials that we will be using a lot during quadratics. So it is helpful to memorize this as well. You can go ahead and write this down in a notebook, pause the video, because this is very helpful. So we have a plus b whole square equals a squared plus 2ab plus b squared, and a minus b whole square equals a squared minus 2ab plus b squared. Okay, that seems pretty cool. So now let's go ahead and put this to use. Let's say we have, okay, I'm not going to erase that because those are really important and we will be needing them later. Okay, here, I'll just keep that there. And then let me get rid of these really quickly. Okay, so so now what if we have this? What if we have 3x plus 15 whole square? Will it hold true with our pattern? Okay, let's find out. What's 3x times 3x? That's 9x squared, right? So that's going to be 9x squared. And then we're going to do 3x times 15. And 15 times 3 is 45. So we're going to add 45x. And then, again, we need to do that again because now once we have that, then we have to do the other side. So now, again, that's going to have to add a 45x. And then, lastly, we have to add the 15 squared. And 15 squared is 225, which results in the same number as 9x squared plus, sorry about that, 9x squared plus 90x plus 225. Okay, well, does that apply to our pattern? Let's take a look. Let's see. So our pattern was a plus b whole squared, right? And right here we have, let's say 3x is a and 15 is b. If we solve, then we get 3x squared is 9x squared. Okay, so we're on track so far. Plus 2ab. So a is 3x, b is 15. 15 times 3 is 45, times x is 45x. If we multiply that by 2, we get 90x. Okay, seems pretty good so far. And then plus b squared, and 15 times 15 is 225, plus 225. So yeah, our pattern holds true for any numbers here, whether we have coefficients, fractions, decimals, square roots. This pattern right here always holds true. whenever we have an a plus b whole square, it will always result in the a squared plus the 2 times the a times the b plus the b squared. And it will also result the same if we have a minus. But remember, if there's a minus, we only change the first sign. We never change the second sign. Okay, let's go ahead and get some practice. So, let's say we're given the... Okay, you know what? Let's do it backwards. This is factoring. This is what we call factoring. When we're given an expression like this. 4x squared plus 8x and then plus 2 times 2 is 4. Okay, let's try that. Now you want even better. Let's try this. Okay, let's work backwards now and do, this. If we have this right here, x squared minus 4x plus 4. Can you guys guess what that equals to? Using one of our 2 patterns that we discovered in this video, go ahead and pause this video and try it before I go ahead and show you guys what it is. Okay, so the solution to this is x minus 2 whole squared. And the way that we know that is we can go ahead and check it. So let's go ahead and check it with our rule. Our rule says that it's a squared, right? And a squared is x squared, so that means our a must be x. So we know that our a is x, so we know our first term here is x. Okay, so next our thing says right here minus 2ab. So we know that 2ab equals 4x. We know a equals x, so we know that 2b equals 4. So that means we know b equals 2. And to make sure that we know that b equals 2 right here, we can always check it with that last term right there, where b squared equals 4, and the square root of 4 is 2. So that's how we know x minus 2 whole squared is the same as x squared minus 4x plus 4. And you can also check it again by plugging it into the formula and then seeing if you get the right answer or not. Okay, now it's time to give you guys a tricky one. So let's say I have this. 4x squared plus 2x plus 1/4. Sorry, that's 1/2. Plus 1/4. What does this evaluate to? Go ahead and pause the video again and see if you guys can solve it. And once you guys are done, go ahead and unpause and check your answers with me. So let's see, if we plug this in, we know that this is plus and plus, so we know to use this formula right here, the first one. So we know that a equals 2x because the square root of 4x is 4x squared is just 2x. So then we can go ahead and write 2x and plus, because the sign right here is a plus, so that means that this must be plus. And now go ahead and check b squared here. So if b squared equals 1/4, then what is b? the square root of 1/4 is the same as the square root of 1 over the square root of 4. The square root of 1 is 1 and the square root of 4 is 2. So you have 1 over 2. So it's going to be 2x plus half squared. And we can also check it by doing it in the middle. Let's see if that fits correctly. 2 times half times 2 is perfect. It's 2x. So there you have it. That is your perfect square trinomials. Please hit a like button and please subscribe for the next video, which is going to be more perfect square trinomials and a new tactic with other equations. Thanks for watching.